In September 2022, the National Aeronautics and Space Administration, or NASA, conducted what many thought was impossible: stopping an asteroid. But before you start partying, let me give you some context. The asteroid that was dealt with wasn't really hurtling its way to Earth. It wasn't destroyed either, but had its trajectory altered. And unlike the 1998 Armageddon movie starring Bruce Willis, there were no human sacrifices or nuclear detonations involved. Instead, it was just a remote spacecraft that was made to collide with an asteroid. And the heroes for this project? They are the folks from the Johns Hopkins University Applied Physics Laboratory, with the assistance of NASA, of course. This historical event was the final part of the Double Asteroid Redirection Test, or DART. Essentially, this project launched a spacecraft in November 2021 and then sped around the Sun for 10 months while chasing its target, a small space rock they named Dimorphos. This particular space rock has a distance of 7 million miles from Earth. While it is true that this space object was too small and too far to threaten our world, the DART project proved our capacity to autonomously target and alter the direction of specific celestial objects, and pretty much a big deal already. After all, being able to hit and nudge the trajectory of a high-speed projectile from space can serve as a thin line between a miss and total catastrophe. But here's the question we want to get answered. Are we capable of destroying asteroids just like we see in the movies? And if we don't have the capacity just yet, what are the alternatives that NASA and other space agencies can explore? For God knows how long, policymakers around the world, not just in the United States, didn't take asteroids seriously. The consensus is that why would we care for things that are outside our backyard when we still have a lot of mess we need to clean up? That point has its merits, but that doesn't eliminate the threats that could potentially be heading in our way. Fortunately, this line of thinking is gradually dissipating because NASA and other astronomers have begun to discover world-ending asteroids that could potentially hit Earth. Dr. Thomas Statler, the program scientist of the DART mission, said that global-scale impacts don't happen that much, around every 10 million years or so. But that doesn't mean that we are already safe. In fact, NASA and other space agencies have been devoting their efforts to finding smaller objects in space that are lingering in our vicinity. They are more numerous than large-scale asteroids, and while they don't have the capacity to end life as we know it, each of them still packs more energy than a nuclear bomb. NASA made it a point that there aren't any asteroids big enough to do significant damage to Earth that are on track within the foreseeable future. I am not confident if this statement from NASA is true, but if that's the case, that's good. However, NASA also warned that there are still asteroids lurking around the Earth, many of which are discovered on a daily basis. According to Kelly Fast, who is a Near-Earth Object Observations Program Manager at NASA's Planetary Defense Coordination Office, the space agency has already identified roughly 30,000 of these asteroids within our yard. But again, none of them are on track to collide with our planet just yet. But when does NASA or any other space agencies declare that we are in danger? There are two factors scientists consider when it comes to raising their alert levels. First is when they spot an asteroid with a brightness over a certain level. This means that such an asteroid might be speeding fast or has a significant size that could pose a danger. The second factor is when such an asteroid is within 4.65 million miles of Earth. In short, this is about 1/20th of the average distance between the Earth and the Sun. By the way, these threats are called potentially hazardous asteroids. Despite the scary terminology being used, potentially hazardous asteroids may also mean that these asteroids aren't a threat yet. To be precise, these are just asteroids that NASA wants to observe. After all, observation and detection are key elements in deflecting cataclysmic events. But this also means that an apocalypse from the sky isn't completely ruled out. That will never happen at all. People who dedicate their lives to astronomy and space science know that asteroids that haven't been detected yet are the most terrifying. These are the ones that can suddenly pop out of nowhere with a distance really close to Earth. And if that happens, it will be too late for anyone to do anything, to even just nudge its trajectory. Just take a look at this image. This specifies the number of asteroids that could potentially hit Earth every year. Most of them are asteroids around 4 meters in size. Every year, 1 out of 500 million of these small asteroids are really close to our planet. When they entered our vicinity, flashing lights could be seen. They don't yield too much ground effect, except for potential meteorites. Let's go to the end of the scale. There are only 4 out of those 10,000-meter-wide asteroids that have been spotted by NASA that flew really close to Earth. Fortunately, these world-enders rarely hit. In fact, there's been one every 100 to 200 million years. The one that killed the dinosaurs 66 million years ago was roughly 10,000 meters in size, and it caused a mass extinction event. So if one hits right now, that could spell our end. Those asteroids that I've mentioned pass the Earth at a distance less than the distance of the Earth from the Moon, or roughly 300,000 kilometers, or 186,000 miles. These incidents are often called close approaches in the context of cosmic scale. Sure, 186,000 miles might sound far, but in the grand scale of the universe, that number is really, really small. And believe it or not, 126 close approaches were recorded in 2022. In 2023, we had 50, which is definitely hair-raising. According to NASA, the asteroid 153814, or 2001 WN5, will pass the Earth in 2029 with a distance of just 155,000 miles. Who knows if its trajectory will change? So what if there's a large asteroid coming in our way? Is there something that NASA can do? Unfortunately, there's none, especially if it wasn't detected ahead of time. We could try throwing multiple nuclear warheads toward the asteroid, but there's no guarantee that it could stop the collision or minimize the damage entirely. Any asteroid that is bigger than 1,000 meters can't be obliterated easily by a nuclear bomb. And even if a bomb is placed directly on the surface of a large asteroid, NASA's calculations suggest that the explosion would just fracture the asteroid into several pieces, and those pieces could still be big enough to cause significant damage to Earth if they are into its trajectory. Because of this, the United States Congress asked NASA in 2005 to develop plans to stop asteroids from colliding with our planet. After 2 years, the Planetary Defense Conference took place, where the space agency presented its ideas on how to deal with these threats. While nuclear weapons are still a part of the discussion, NASA mentioned that they aren't going to be used to explode an asteroid. Instead, they will use the momentum of their explosion to hopefully nudge asteroids and alter their trajectory, effectively preventing our civilization from being wiped out completely. NASA already had tested 4 nuclear scenarios to see which are the most effective: a surface explosion, delayed surface explosion, subsurface explosion, and standoff explosion. Among them, standoff explosions are deemed to be the safest and most effective in deflecting an asteroid. If there are no nuclear weapons involved, our best possible chance to avoid a heavenly cataclysm is by a kinetic impact, similar to the DART mission. The idea is to ram objects into the asteroid to push it away from its predicted trajectory. But there's a challenge here, as space agencies have to identify the surface of the asteroid first. And that's not an easy thing, especially if the asteroid came undetected. Other non-nuclear options include the use of a giant mirror or laser, but let's face it, these technologies are difficult to build. Furthermore, our biggest problem here is how to fund these asteroid defense plans. The DART mission is a start, but it will take millions or billions of dollars to create solid mechanisms to keep Earth safe from these interstellar threats. And to be honest, I don't believe that this mission will be our government's top priority. Space agencies and institutions receive lesser and lesser funds every year, but the irony here is that we expect big things from them. So I guess the message of this video is this: let's promote the advancement of science. Instead of fighting wars and funding useless projects, we should pour our attention into fostering science and technology as a whole. Because if we can't do this, then there's no stopping a single asteroid from erasing life as we know it. Thanks for watching. If you enjoyed this deep dive, please subscribe to Beyond Life. I know doing these things is a chore, but with those little clicks, you can help our channel grow and allow us to produce more value-oriented content just like this. That's it for now. Stay safe and see you in the next one.